This is the final video homework guide for the optimization questions. And for this next example, I need to find the coordinates of the point xy on the curve of this parabola that's closest to the point 0, 1. All right, so let's go ahead and draw a little sketch of what's happening in this problem here. So I'm given the equation of this quadratic function, and it opens down. And there's a point 0, 1, which is right about here. So there's the point 0, 1. And from the point 0, 1, there's going to be another point somewhere on the parabola. I'll label this x, y. And I want to find the shortest distance, which is, in theory, perhaps this line right here. So if I'm given this parabola with the point 0, 1, I want to find the shortest distance from that point 0, 1 to a point on the parabola. In this case, let's label it x, y, and I want to make sure that that coordinate is the shortest distance possible to the point 0, 1. Okay, so we are trying to minimize the distance in this particular problem, and if we want to minimize the distance, we need the distance formula between 2 points, and that is the square root of x minus x1 squared plus y minus y1 squared. And for this particular problem here, the x and y variables, they really represent the x and y variables here, and the x1 and the y1, sorry, that represents the 0 and the 1 variables over there. All right, so that's the x1, that's the y1, and that's the x, and that is the y. So I apologize if I didn't say that correctly, but hopefully the colors there will navigate you to the right variables. Okay, let's get rid of all this now. After that, let's go ahead and plug in the points that we have, which are 0 and 1. So this will be x minus 0 squared plus y minus 1 squared. So this 1 is really that 1 there, and that 0 is that 0 over there. And once again, this x is that x there, and that y is that y over there. Okay, let's go ahead and simplify this as much as we can. If I take a look at this expression right here, x minus 0 to the power 2, that's simply going to be x squared. And then I have this plus, let's leave this as y minus 1 squared for now. Okay, so with any optimization problem, once you have your derivative equation, eventually you want to take its derivative, but the problem is you have two variables again. So we need to go and look at our helper equation and see if we can make a nice substitution step. Okay, so if I take a look at my problem here, the helper equation, which I will maybe write over here now, the helper equation, just running out of space on the other side, so I will write the, whoops, can't write over here, so all right, the helper equation, if I take a look at this particular problem, the only kind of information that kind of may help me is this equation here. And so the helper equation is just going to be the equation of the parabola by default, so y equals to 4 minus 1/2 x squared. So that's the equation of the helper here. And what we're going to do now is we got to replace one of the variables with something in the helper equation. And a lot of times we usually substitute for y here, but the problem is there's a minus 1 there, and then we have to square all that. So that's going to create a lot of algebra there. So you can definitely replace the y variable, but it just takes a lot of work in the next few steps. So we can also look at the x squared term. So can we replace that with something in the helper equation? Okay, well there's the x squared term. Let's see if I can isolate for that. So if I do that, that's going to be 1/2 x squared equals 2. So I'm going to leave the 4 here, and then I'll bring the y to the other side. So that's going to be 4 minus y. Okay, and then I can multiply everything by that 2 there. So this will be x squared equals to 8 minus 2y. And that works out really nicely now because here's x squared, and x squared is equal to 8 minus 2y. So I can replace the 8 minus 2y with the x squared over there. Okay, let's erase all that, erase that, and let's go ahead and write in 8 minus 2y. And if I do that, the algebra is going to work a lot nicer in the next steps here. So now let's go ahead and continue to simplify this. This will be 8 minus 2y. And then if I take a look at this y minus 1 squared, y minus 1 all squared, that's going to be plus y squared minus 2y plus 1. And after that, we can rearrange the terms here and clean this up. So the y squared would go in the front there. I have a minus 2y and a minus 2y, so that's going to be minus 4y. And then 8 plus 1 is going to be 9. Okay, so that's simplified in a very nice way here, and now I need to take its derivative here. So d prime. Now I know this is going to be the same thing as y squared minus 4y plus 9 to the power 1/2. So if I use the power rule here, I know that the 1/2 will come in front. So 1/2 bracket bracket y squared minus 4y plus 9 to the power of negative 1/2. Right, so that's simply using the power rule, and then the chain rule states that I need to take the derivative of this inside term, and that's going to be 2y minus 4. All right, let's rewrite this back into a radical. So this 2y minus 4 can remain on the top, all divided by, well, this part right here, that will be on the denominator as y squared minus 4y plus 9, and this 2 here can just remain on the bottom. All right, so that derivative is going to be equal to 0, and whenever you have a fraction equaling to a 0, you just focus on the numerator here, and you just set 2y minus 4 equals to 0, 2y would equal to 4, divide both sides by 2, and the y value is positive 2. Right, so that's looking pretty good. Let's go back to our original setup here, and let's just see if we can use this number here to help us finish off the rest of the problem. Okay, so let's go back to the diagram here. Okay, so what we just found here was that this is now going to be 2. Right, let me just erase all this, and I need to find the coordinates, right? So I still need to find the x value there, and remember the equation of this parabola is y equals to 4 minus 1/2 x squared. We now know that 2 is the y variable, or sorry, 2 represents the number for the y variable, so this will be 2 equals to 4 minus 1/2 x squared. Let's bring the 4 across, so that's going to be 2 minus 4 equals to negative 1/2 x squared. Let's continue to figure this out. So that's going to be negative 2 minus 1/2 x squared. The negative signs cancel off. This 2 can multiply with that 2, so 2 times 2 is going to be 4. And then finally you can square root both sides, and that means the x value will be plus or minus 2. Okay, so what that really means is if I have plus or minus 2, that means this could be a positive 2, and I can also have another point over here with a negative 2, and I guess that height will also be 2. So the coordinates are negative 2, comma 2, and 2, comma 2. Those coordinates would represent the shortest distance from the parabola to the point 0, comma 1. Okay, so I apologize that my diagram is not to scale, but I feel like I went over the main concepts there. Okay, let's go to the final problem in this video homework guide here. This problem, I have a rectangle. So the rectangle is this shape right here, and it has 2 vertices on the x-axis. So there's a few vertices on the x-axis there, and it's inscribed under the curve y equals to e to the power of negative 2x squared. So I'm assuming that this equation right here is this graph right here. So you have a rectangle that's inside that particular exponential function there. And I need to find the maximum area of the rectangle. All right, so if you want to maximize the area, you need to have a area formula for the rectangle. And the formula for the area of a rectangle is length times width. And in this diagram here, let me just kind of blow this up here if I can. Let me just erase all this. Here's my length right here, green distance, which is really just the y variable there. And then I have this distance right here. Actually, I'll use an orange. I have this distance right here, and I also have this distance right here representing the base there, or the width. We can denote this orange region as just a single x, and I can denote that purple region as a single x. So x plus x, the purple x plus the orange x is going to be 2x. So this whole length right here is really going to be 2x. And we know that this height is going to be y. So if I want to find the area, it's going to be length times width. Let me write down area equals length times width, which is simply going to be the 2x times the height, which is y. So 2x times y. That is my formal area equation there. Okay. After I have my area equation, we want to take its derivative, but there's two variables, x and y, so I need a helper equation. So if I go back to my problem here, this is going to be my helper equation right there. All right, so this is very similar to all the previous problems. We're just giving you a exponential function in this case. So the area is going to be equal to 2x times y. So area would be equal to 2x times y, which is going to be e to the negative 2x squared, all in closed brackets. Okay, let's go ahead and take its derivative now. So a prime, we have to use the product rule here. All right, so it's going to be 2x times e to the power of negative 2x squared. So the derivative of 2x is going to be 2. So 2 times e to the negative 2x squared, close the bracket, plus, and then I have a 2x here. And then what's the derivative of e to the power of negative 2x squared? Well, that's going to be e to the power of negative 2x squared. And then we multiply by using the chain rule, which is taking the derivative of that power there. And the derivative of negative 2x squared is negative 4x. Okay, after we have taken our derivative here, we want to take our derivative and say equal to 0 here. So now we've got to clean up the right-hand side here. I see that I have this term and that term. Those are common in both terms, so I can factor that out. So that's e to the power of negative 2x squared. And then what's left? I have the green 2. And then if I take this 2x and multiply it with the, if I multiply this and this, that's going to be negative 8x squared. And there we go. All right, so if I set this equal to 0, remember that when you have an exponential function, this is never equal to 0. So now we can focus our attention on this part right here. So that's going to be 2 minus 8x squared and make that equal to 0. So 2 equals to 8x squared. And then we divide both sides by 8. And we get what? 1 over 4 equals to x squared. And after that, we take the square root of both sides. And if I do that, I get plus or minus 1 over 2. Okay, in this particular problem, although we get x equals to plus or minus 1/2, I believe that the x has to be positive, so we now know that x equals to just positive 1/2. So we need to reject the negative answer. And now I need to find the maximum area. Okay, well, if I take a look at my work here, let me just erase all of this, erase all that. In this problem, we had already defined our area to be this particular, expression right here. And now we know that x equals to 1/2 based on our answer after doing all the algebra and taking its derivative and saying equal to 0. You just take that 1/2 and you plug it in there and just find your overall area. So let's do that to just finish off this particular problem here. So 2 times 1/2. And that's going to be e to the power of negative 2 times by 1/2. And that's being all squared. Okay, so we're almost done here. I guess the 2 and that 2 will cancel off. So I have e to the power of negative 2. And then if I take all of this, 1/2 to the power of 2 is going to be 1/4. And if I go ahead and simplify that, this 2 and that 4, they will simplify to 1/2. So the final answer is e to the power of negative 1/2. And that is my final area there. Okay, so that concludes this video homework guide for the optimization problems.